In 1986, astronomers discovered 3753 Cruithne, an asteroid with a unique relationship to Earth, intriguing scientists due to its orbit's unusual interaction with our planet's gravitational field. Named after the ancient Picts of Scotland, Cruithne's mysterious celestial nature echoes the mystique of these early inhabitants. Unlike most near-Earth objects, Cruithne's orbit doesn't align with typical patterns. Its path, influenced by Earth's gravity, results in a horseshoe orbit, sometimes leading to its mistaken identity as Earth's second moon, although it doesn't orbit Earth in the traditional sense. Cruithne is considered a quasi-satellite, as it shares an orbital resonance with Earth without being a direct satellite. This classification involves a complex gravitational dance, influenced by both the Sun and our planet, keeping it in a loosely bound orbit near Earth. The horseshoe shape of Cruithne's orbit stems from a gravitational tug-of-war between Earth and the Sun. This interaction causes Cruithne to follow Earth in a looping pattern, moving back and forth over time while maintaining its distinct path. The gravitational relationship between Earth and Cruithne is complex and dynamic. While primarily influenced by the Sun's gravity, Earth's pull creates resonance, keeping Cruithne in its unique quasi-satellite orbit. Cruithne's chaotic orbit results in varying gravitational interactions, leading to fluctuations in speed and position. Despite this chaos, its general orbit shape remains consistent, and its relationship with Earth will likely persist for thousands of years. Although categorized as a near-Earth object, Cruithne doesn't come close to Earth, maintaining a minimum distance of about 12 million kilometers. This vast separation ensures no collision threat, distinguishing it from the Moon. Cruithne's orbit spans approximately 385 years, with periodic close approaches to Earth before moving away. This cyclical pattern, along with subtle shifts in its path, keeps scientists monitoring its movement closely. Astrophysicists find Cruithne valuable for studying gravitational resonance and orbital dynamics, offering insights into how bodies can maintain stable orbits without direct gravitational binding. Cruithne serves as a model for how near-Earth objects might behave under similar gravitational conditions, aiding research on predicting and tracking asteroid paths with implications for planetary defense. Understanding Cruithne's orbit helps in developing models for asteroid trajectories, crucial for identifying and mitigating potential threats from space. Its study informs efforts to alter or deflect hazardous asteroids. The public's intrigue with Cruithne stems from its second moon label, fueling myths about its relationship with Earth, despite being scientifically inaccurate. Cruithne has become a cultural touchstone, referenced in media as an example of the solar system's complexity and the unknowns that exist in space. Astronomers predict Cruithne will maintain its quasi-satellite orbit for millennia, though slight changes may eventually alter its trajectory, possibly leading it away from Earth in the distant future. Comparisons with other quasi-satellites highlight the diversity of small bodies' orbital patterns near planets, revealing the complexity of gravitational interactions in the solar system. Cruithne's unique orbit makes it an intriguing candidate for future exploration, despite current distance challenges. Advances in technology may enable a mission to study it up close. A mission to Cruithne could provide valuable data on its composition and dynamics, contributing to our understanding of quasi-satellite behavior and asteroid materials. Such a mission might also aid in developing techniques for asteroid deflection or capture, relevant for planetary defense strategies against potential collision threats. Though not visible to the naked eye, astronomers track Cruithne using telescopes, capturing images and estimating its size to be about 5 kilometers across. Simulations of Cruithne's orbit visually represent its horseshoe shape, helping the public understand its interaction with Earth's gravitational field through animated depictions. Cruithne's unique status makes it a popular subject in astronomy education, explaining concepts like gravitational resonance and quasi-satellites to diverse audiences. Its unconventional orbit challenges traditional notions of celestial mechanics, offering a teaching tool for illustrating the diversity of solar system orbits. Discussions of Cruithne also explore topics like near-Earth object tracking and planetary defense, broadening its educational scope. Amateur astronomers are drawn to Cruithne's orbital characteristics, even though it's too distant for most backyard telescopes, sparking interest in forums and groups. Tracking Cruithne requires sophisticated methods, including radar observations and mathematical models to predict its future path over long periods. Astronomers refine orbit models through data on gravitational perturbations from other planets and the Yarkovsky effect, enhancing predictions of Cruithne's path. Cruithne's study not only enriches our understanding of gravitational interactions, but also prepares us for future exploration and potential planetary defense challenges. Thank you for joining me on this journey. Your support means a lot, so please consider subscribing, leaving a comment, and liking the content. Each action helps sustain and grow this channel.